So, for our problem, I'm Josiah Guerra and my partner is Daniel.
Daniel Subanek.
And we chose example 1C3, which is the one we did in class. So from our book, we can see that we are given the r equals 4 plus 2 theta, and we're given theta equals pi, and theta dot equals 3 radians per second. And this is the schematic that we're given of the particle or of the coordinate system. And for the problems, we're finding the acceleration vector of point P, and we're finding out if it is increasing or decreasing. Am I right?
Yes.
Okay. So for the solution for A, we first use the acceleration formula that we were given in class, which is r double dot minus r theta dot squared e hat r plus r theta double dot plus 2r dot theta dot e hat theta.
What a mouthful.
What a mouthful. And so using the given information, we can find the thetas, theta dots, theta double dots, and the r's, all of them. So we have theta equals pi, theta double dot is 3 radians per second, which is a constant. So that makes theta double dot 0. So for r equals 4 plus 2 theta, r dot of that is 2 theta dot. And then derivative of that is r double dot equals 2 theta dot. And so since we already have the thetas, we can just plug it right in. So r equals 4 plus 2 theta, which equals 4 plus 2 pi. R dot equals 2 theta dot, which is 2 times 3, which is 6. And r double dot is 2 times double dot theta, which is 2 times 0, which is 0. And then since we have all that, pretty much just plug and chug. So just plug in the r double dot, which is 0, just plug it all in. So it's 0 minus 4 plus 2 pi times 3 squared e hat r plus then this equation, r double dot plus 2r dot theta dot. So we have 4 plus 2 theta, which equals 4 plus 2 pi times 0 plus 2 times 6 times 3. And then basic algebra, simplifying it all, we get it down to negative 36 minus 18 pi e hat r plus 36 e hat theta. And so the acceleration vector of P is negative 36 minus 18 pi e hat r plus 36 e theta hat meters per second squared.
So for part B of this problem, we have to figure out, is A, or P in the problem, is it decreasing or increasing in speed? Now there's only one coordinate system that will tell us if P is increasing or decreasing, and that is path, because we're looking for the attachment to ET hat, which is V dot. So in order to find that, we'll have to convert the polar coordinates that we were given into path coordinates. However, we don't know the direction of ET hat or EN hat, so we're going to have to do a little bit something different than just straight cosine and sine thetas. We're going to have to use this equation here, which is V dot equals ET hat dot A vector, which is the dot product simplification. So how would we find ET hat, you'd say? Well, first, we remember that ET always points in the direction of motion. So that means it'll be, and it's always a unit vector, which means that the sum squares of its parts equals 1. So for this one, we'd have to first find the velocity vector and then normalize it by dividing by its magnitude. So over here, we got our velocity vector, which is just given in our paper using the polar coordinate systems, which is r hat, er hat, or r dot, er hat, plus r theta dot, e theta hat. And so from previous part A, we can see that r dot is 6, and r theta dot is equal to 3 times 4 plus 2 pi. And we can simply find the magnitude using the Pythagorean theorem, and it comes out to a pretty nice 31 meters per second. So then we'd have to simply take this velocity vector here and divide it by its magnitude to get its normalized form. Now the acceleration vector, which is what we just calculated, is here of minus 36 minus 18 pi er hat plus 36 e theta hat. Now we need to do the dot product, which is simply taking ERs or ER hats on each vector and multiplying them, and then adding that to the multiplication of E thetas and add them all together, and it'll give us a scalar, which is exactly what we're after, finding V dot. Now doing that dot product multiplication, all the simplification steps have been omitted for the sake of space and clarity. We end up getting 17.7 meters per second squared. Now notice that 17.7 is greater than 0, so that means that the speed of A is in fact increasing.